Space, the final frontier. We imagine a sky teeming with stars, astronauts gazing upon a celestial tapestry unseen from Earth. This expectation is ingrained in our cultural understanding. From childhood, vibrant illustrations depict spacecraft soaring through stars. These images fuel our fascination with space. We yearn to see what astronauts see. On a clear night, we see thousands of stars. Venturing further, we expect to see more celestial objects. But capturing stars in space is not straightforward. It's a fascinating interplay of light, technology, and our senses. The absence of stars in many space photos is due to exposure settings. Cameras, like our eyes, need the right amount of light for clear images. Too little light results in underexposure, too much in overexposure. Stars are faint light sources from vast distances. Capturing stars requires longer exposure times. Objects like astronauts need shorter exposure times. They reflect sunlight, making them brighter than stars. Hence, space photos often show a dark, starless void. The way cameras capture light differs significantly from how our eyes perceive it. Our eyes are incredibly adaptable, constantly adjusting to varying light conditions. We can discern details in both bright sunlight and dim starlight, although not simultaneously. When we look at a bright object, our pupils constrict, limiting the amount of light entering our eyes. Conversely, in low light conditions, our pupils dilate, allowing more light to reach our retinas and enhancing our ability to see in the dark. This dynamic adjustment allows us to perceive a wider range of brightness levels than most cameras. Furthermore, our brains play a crucial role in processing visual information. They filter out noise, enhance contrast, and combine images from both eyes to create a three-dimensional understanding of our surroundings. This complex interplay of biological processes allows us to perceive stars in the night sky, even though they may appear faint to the naked eye. Cameras, on the other hand, have a fixed sensitivity to light. While they can be adjusted to some extent using settings like ISO and aperture, they lack the dynamic range and processing power of the human visual system. This limitation contributes to the difficulty of capturing both bright objects and faint stars in a single image. On Earth, light pollution plays a significant role in obscuring our view of the stars. The artificial light emitted from cities, towns, and even individual homes scatters in the atmosphere, creating a luminous haze that drowns out the faint light of distant stars. This phenomenon, known as sky glow, is particularly problematic in densely populated areas, where the combined light from millions of sources can make it nearly impossible to see stars without the aid of telescopes or traveling to remote locations with darker skies. The brighter the surrounding environment, the more difficult it becomes for our eyes to perceive the faint light of stars. In contrast, space is devoid of atmospheric light pollution. With no air to scatter light, the sky appears black even when the sun is shining. This pristine darkness provides an ideal backdrop for observing celestial objects, as there is no competing light source to interfere with their visibility. However, the absence of atmospheric light pollution in space does not guarantee the visibility of stars in photographs. As discussed earlier, the primary factors influencing their appearance are the camera's exposure settings and the relative brightness of other objects in the scene. Section 5. Artificial suns. Human-made light in space. While space itself may be free from natural light pollution, human activities have introduced a new source of illumination: artificial light. Spacecraft, satellites, and even the International Space Station are equipped with powerful lights used for various purposes, such as communication, navigation, and illuminating work areas during spacewalks. These artificial light sources, while essential for space operations, can contribute to the difficulty of capturing stars in photographs. Just like city lights on Earth, these lights can overpower the faint light of stars, making them difficult or impossible to see in images. Moreover, the reflective surfaces of spacecraft and other man-made objects in space can further exacerbate this issue. Sunlight bouncing off these surfaces can create glare and reflections that interfere with the camera's ability to capture the subtle light of distant stars. Therefore, even in the darkness of space, Human-made light sources can create a form of localized light pollution that affects our ability to observe and photograph stars. This highlights the importance of careful planning and consideration when designing space missions and conducting astronomical observations. Section 6. A Tale of Two Perspectives. Moon versus ISS photography. Comparing photographs from the Moon and the ISS shows how perspective and environment influence star visibility. Apollo mission images show a stark, airless landscape with a pitch-black sky. The absence of stars is due to the Moon's lack of atmosphere and bright sunlight. In contrast, ISS photos often show a vibrant Earth with faint stars visible. This difference is due to the ISS's lower orbit and Earth's atmosphere. Section 7. Beyond the Lens, Understanding Light for Exploration. Recognizing the challenges of capturing stars in space photography is not merely an academic exercise. It holds significant implications for future space exploration and our understanding of the universe. As we venture further into the cosmos, our ability to accurately observe and interpret celestial objects becomes increasingly critical. For instance, future missions to Mars and beyond will rely heavily on celestial navigation, using the positions of stars to determine spacecraft orientation and trajectory. Accurate star identification and tracking are crucial for ensuring mission success and the safety of astronauts. Furthermore, space telescopes, like the James Webb Space Telescope, rely on precise light management to observe the faintest and most distant objects in the universe. Understanding how light interacts with spacecraft, instruments, and the space environment is essential for maximizing the scientific return of these missions. By studying the factors that influence star visibility in space photography, we gain valuable insights into the nature of light, the limitations of our instruments, and the challenges of observing the cosmos. This knowledge informs the design of future missions, the development of advanced imaging techniques, and our overall understanding of the universe. Section 8. The Future of Stargazing Adaptations and Discoveries. Despite the challenges, capturing the awe-inspiring beauty of a star-filled sky from space remains a goal for many photographers and astronomers. Advances in camera technology, image processing techniques, and our understanding of light are constantly pushing the boundaries of what's possible. New generations of cameras with higher ISO sensitivities and wider dynamic ranges are becoming increasingly available, allowing for better low-light performance and the ability to capture a greater range of brightness levels in a single image. These advancements will enable future space missions to capture more detailed and spectacular images of stars and other celestial objects. Furthermore, sophisticated image processing techniques can be employed to enhance the visibility of stars in existing space photographs. By carefully adjusting contrast, reducing noise, and applying specialized filters, faint stars that were initially invisible can be revealed, providing a more accurate representation of the scene. As we continue to explore and understand the universe, we can expect to see even more breathtaking images of stars captured from space. These images will not only inspire awe and wonder, but also provide valuable scientific data, helping us unravel the mysteries of the cosmos and our place within it. Section 9. Conclusion. The universe, awaiting our gaze. The absence of stars in many space photographs, while initially counterintuitive, reveals a fascinating interplay of light, technology, and human perception. It highlights the importance of understanding camera settings, the limitations of our own senses, and the impact of both natural and artificial light sources on our ability to observe the cosmos. As we venture further into space, our understanding of these factors becomes increasingly crucial for successful exploration, scientific discovery, and capturing the awe-inspiring beauty of the universe. By embracing the challenges and continuing to push the boundaries of technology and our own understanding, we can unlock the secrets of the cosmos and inspire future generations to reach for the stars. The universe, with its countless stars and celestial wonders, awaits our gaze. It is up to us to develop the tools, techniques, and knowledge necessary to capture its full splendor and unravel its mysteries. The journey of exploration is just beginning, and the stars are our guide.